Okay, everyone, welcome back. Today we're going to get back to our AI for fishing in World of Warcraft. Today, I'd like to do two things before we continue. First, I want to refactor our code quite a bit to kind of get it ready for the next step. And then I also want to talk about color space, because the current color space that we're using is BGR. As you know, we converted our RGB image to BGR. But actually, we're going to see that that's probably not the best color space to work in for what we're trying to do, which is visually watch a bobber move and compare the colors that we see with our eyes. So RGB is not usually the best way to do that. The HSV color space is a better choice. So we're going to be making a few small changes to the code, so this might be a short video. So the first thing that I want to do is I want to update my main agent class to include a few more things. So first, we're going to include a list that's going to store agents. And what this is going to do is this is going to store any other agents that are running. So if we have an agent for fishing, if we have an agent that was to look at our health, if we had an agent to look at our mana, if any other, you can kind of think of the main agent as the boss, and then we have all these sub-agents that are going to do different specific activities. So this is where we're going to store them in this list. Next, I'm going to create a variable for the fishing thread, which we have not implemented yet, so we're just going to set that as none. Okay, and then I'm going to change the word screenshot just so that it matches the original program or the original project that we did. That I shared. We're going to call this the current image. So this is the current image that's going to be live on the desktop. And then we're going to add another one called cur image HSV. And this is where we're going to store the HSV color space version of that same image. And as I mentioned, that's going to help us with visually detecting changes in images. Okay. And then I have a few more things in my project. I have self.zone, and I just hard coded this in for now. This is just a placeholder to kind of show the functionality. And you could put a World of Warcraft zone in there. And what this is going to do is once we get into the color detection and movement detection, different zones have different looks and feels, and they create like an ambiance on the screen. And in like Feralis, for example, the example that I showed, it's kind of got this green overcast tone to it, which makes detection of the image a little bit more difficult. If you have the bobber in a different location, then the tones of the picture are going to be different. So this is going to help improve our color detection. And if we were to make this a very, very complex and smart agent, we would want to probably have it track exactly where we are in the world, so it kind of knows visually what we're looking for. So anyways, that's what that's going to be used for. And then we're going to have self.time, and I have this just hard-coded to night. Again, same reason, is that day and night cycles in World of Warcraft are going to visually change what the agent is going to see pixel-wise, color-wise, and we're going to probably have to adjust for what it's looking for depending on whether it's day or night. So those are all of the current things that are going to be stored in our main agent. Okay, and then we can leave this in here, this main agent setup complete. Okay, we have our UpdateScreen function, which is the same as before. But what we're going to do different this time is we're going to actually pass we're actually going to pass an agent into this. So instead of this just being a standalone function with no arguments, we want to pass an agent in. And the agent is going to end up being the main agent. So when we start UpdateScreen, we want to store this screenshot into the current image for the main agent, okay? So let's actually just rename this just so that it stands out a little bit, gives us a little bit more practice, I guess. So instead of storing this in screenshot and creating a new variable and all that, we don't even need to do that. We can just directly access agent now since we've passed it into this function. So we're going to call this agent.curImage, and we're going to set the agent's current image as the image grab. And then like before, we're going to make some modifications to that image, and we're just going to overwrite it since we don't need to store separate versions of that. So after these 3 lines of code execute, any instance of main agent that's running UpdateScreen that has been passed into UpdateScreen is going to contain the live image from the desktop, which is what we want. We want this agent to be able to access that constantly. And I'm going to turn off, well, I guess we can leave it on for now. Oops, not self, agent.curImage. So again, we can show that. So let me quickly execute this code just to make sure what we did, it hasn't broken it too bad. And we did break something, so we're missing an argument. UpdateScreen is missing. Oh, okay. So I didn't actually pass it in. So now what we have to do is, if you remember, we created a thread, and that thread is going to start UpdateScreen, but we told it that it has no arguments, and of course it takes an argument. It takes agent. So what we need to do is we need to pass our instance of the main agent into, this is the instance of main agent, a new class that was created, instantiated. We need to pass this into this argument so that when the thread starts, it'll put that agent in here, and then of course it'll execute the code properly. So for arguments, we need to put in our main agent. Okay. And this is a tuple that can take multiple arguments. So if for some reason we hit agent 1, and let's say we had some sort of thread that took 2 agents, agent 1, agent 2, we could put multiple arguments in there. That's how that works, but we're not going to need to do that here. Okay, so now let me save this and execute. Let's make sure it's working properly. Okay, great, it is. So we have our UpdateScreen function being run, and it has access to our instantiated agent that is storing the variable. So our agent now has this live screenshot continuously being made available to it. Okay, so let me press Q to quit, and it looks like we quit. Okay, so the next thing that we want to do is we want to create, like as I mentioned, we want to not only store the current image as an BGR, we need to store an HSV version of that image. So we will basically do the same thing here. So let's create another. So now we can access agent.curImage HSV, since we still have access to agent, and that's going to be equal to cv.convertColor. We're going to access the current image as our matrix, and now for the code we want to convert from BGR, since this is in BGR, to HSV. So we're going to do cv.color underscore BGR to HSV. Okay. Oops. Let me save that. So now we actually have 2 screenshots. Every time this loop iterates, we're going to have the BGR stored here, and we're going to have the HSV stored here. So maybe I'll add a comment. This is our BGR image, and this is our HSV image. Okay. Okay, now another thing that I want to do is I want to update our main function here, the entry point to the application, and I want to make a couple of changes that are going to maybe add some quality of life, or maybe just add a little bit of functionality, kind of for teaching purposes as well too. So the first thing that we want to do is we want to ask the user to maybe decide what to do, right? We want to give the user some options to start and stop it, kind of like the functionality that I showed in the demo. So we want to start the application. We want to create our agent like we've done here, but before we start executing any code, we want to capture user input. And I've actually created a function that I called print menu. And all this is going to do is print something to the command line to give the user a prompt. So let's just define this as print, enter a command, and then we can do a tab. This just kind of makes it look a little cleaner. And we can say the S key, and then this is going to start the main agent. And then we can say print so this is, I'm just copying what I did last time so we can kind of keep it similar. This will let us set the zone variable, print, and then the F key, we'll let this, this will start the phishing agent. Okay. And then we'll do print Q quit. So we'll quit this thing when we press Q. Okay. So now what we want to do is we want our main loop to be here. So we're going to do a while true loop. So this is going to happen, continuously. So first thing we want to do is we want to print our menu. So we want to tell the user that there's a input that's required, and what we're going to do is we're going to capture that input. So we're going to say user input equals input, and we want to account for capitalization and white space and that sort of thing. So let's overwrite that as user input or string dot to lower. String dot lower user input. So that's going to take, whatever they type in, if it's capital or lower, it's going to make sure it's lowercase, and then we're going to strip that. So that'll remove white space. So if they accidentally did S with a space, or it gets rid of the new line and all that kind of stuff. So we should just have a character. Okay. And then let's just do some basic logic here. So if user input is S, we're going to do something. If the user input is Z, we're going to do something. And if the user input is F, we're going to do something. I put an extra space there. If the user input is Q, we want to quit. And then if it's anything else, we want to say print input error, and then we'll print the menu again for them. Okay. So if Q is pressed, this is where we want to exit the application. So we can say print exiting application, and then we can break this loop. Or you know what? Let's do this. We'll break the loop here, and then when we get to the end, when we get outside the loop, we'll say done. How's that? Okay, so it's going to break the loop when we press Q, and then it'll say done. So we can actually test that real quick. Okay, so let's see how this looks. So now we're getting something that's starting to look like an application. So we have this main agent setup complete. We actually don't really need to see that. So let's try Q, enter, done, quit, okay. And of course, that wasn't a bug. That's because we haven't moved yet. So after this loop broke, it then went into what we wrote before. So just ignore that for now. So, okay. So it looks like that's working right. Let's get rid of this main agent setup complete. I don't think we really need to show that to a user. Okay. So the S key is where we're going to want to start like our main thread, like we talked about, the main agent and our update thread. So if the user presses S, what we want to do is this is where we want to create and start our thread. So let's move this into here. Make sure you got your tabs in the right spot here. So, oops, it's got to go over 2 more. Okay, let me add some space here to make this a little more clear. Okay, so if the user presses S, we're going to create a thread. We're going to call this the UpdateScreen thread, right? And we're going to set this as a daemon false, and we're going to start this thread, okay? And let me put the thread printed in there, thread started in there as well, so we know that we started a thread. Okay, so let's run the application now. And yeah, I was gonna, well, let's run it. So S, okay, so now we've started a thread, and the thread's running, okay? And actually, let me turn off the FPS since it's going to take up the console. Let's turn that off for now. Okay, let me start a thread. So we've started the thread, okay? And the thread's running, so that looks good. Okay, so in the last video, we talked about the daemon. So we have a while loop here that's kind of acting as our main loop. And we have the ability to start a thread. And if daemon, however you say it, is set to false, you're going to have some problems when you break out of this main loop. So this is where the daemon starts to become important. So let's run this and see what happens. So I'm going to start the application, and everything's fine. But the problem will happen when I try to quit. Okay, it gets stuck. This thread is still running because it's not a daemon, and it hasn't broken. So this while loop is still running. So the whole program is kind of waiting for that to finish. Okay, so that's the problem. So I killed that hard, and now I got to kill this hard. Okay. So what we want to do now, since we have a while loop that this daemon is kind of, you know, is supporting, we want to set daemon now to true, and this is going to work better. So when daemon is true, and I run this, and I start a service like that, okay, it's working. Now when I run quit and hit enter, the program exits as you would want. It closes that process. It ends that process. So that's why daemon is important, but it has to be called from within another service that's running. If it's your main service, like you saw in the last video, we had to change it back to false. So just keep that in mind, okay? Okay, so I've opened up the image that we used last time for the phishing demo, and I opened it up in GIMP, and I just want to show. Well, I haven't really explained yet how we're going to identify the bobber, but to make a long story short, we're going to use the pixels that are in these feathers here, since they're a little bit unique. There's a blue and a red section. It's kind of unique, and it's kind of easy to pull out. If we were just to use red, then it might get confused with some of these other items, but you know, we wanted to try to find something that's a little bit unique. So this area right here is a little bit unique, probably to the whole screen at any given time. And I want to just quickly show the color space. So the next video we'll be talking about how to find this and actually put the mouse on it. And but before we do that, I want to explain the HSV and why we're using HSV color space very quickly, and then we're going to end this video. So if I choose a color here in this reds, and by the way, you can also see how this zone that I'm in called Feralis, the whole thing is kind of a green overtone. If in another zone, the fishing bobber doesn't quite look like that, it's a little bit brighter, so that's why we need that adjustment for the zones. All right, so if I pick a color in the dark area, you can see our RGB is 28, 31, 18. Now let me pick a RGB in the lighter part of the feather, like over here, and you can see we're 46, 55, 27. Okay, so a couple of the numbers moved, and then if I get into the blues, 21, 48, 44. So even going from red to blue, there's not really a huge change. So like if I take this dark red, it's 28, 31, 18, and let's say I choose this dark blue right on the other side, it's 16, 32, 30. So there isn't a huge change percentage-wise from 0 to 255. They're both kind of similar, even though visually, yeah, they're both dark, but visually one's red and one's blue. So that's kind of the problem with working in RGB color space. So let's do the same analysis, but let's look at it with HSV. So if I choose this dark red and I switch over to HSV color space, I have 73 for the hue, 41 for the saturation, 12 for the value. Okay, 73, 41, 12. And if I go to this blue, I have 169, 47, 14. So the hue had a huge change. So we can use the hue in this case to easily track between this side and this side. If we're using RGB, all the numbers are so close that a couple little changes, 5, 10, 15%, and before you know it, you're having a difficult time to distinguish. But here it's almost double, triple, quadruple in some cases. And then let's also look at, so let's look out here too. So I have this red, like these red colors that are lighter. So 70, 54, 20. And then if I go right across to this green water, so I have 115, 55, 29. So again, where those reds and even these lighter reds, let me try this really light red. That's probably as close as we're going to get to the water. This is only a hue of 80. So if we set a threshold, for example, in this case as a hue of 100, you're going to easily see that all this green water, the hue value is going to be over 100. And even the closest, lightest red with that green overtone, even as close as that is to that green, in the hue, in the HSV color space, the hue is off enough that it's very easy to track that versus using the RGB color space. So that's why we're going to be working in HSV. I wanted to share that with you. In the next video, I'm going to end the video now. This was a simple one. We just did some code updates, made the program able to start and stop. And I just wanted to show you the HSV color space. In the next video, we are going to actually learn how to find this on the screen live and put our mouse on it. So that's going to be a huge jump. So we're going to go to actual automation in the next video. So look forward to that. Thank you and have a great rest of your day. Bye.